faster, less CapEx, more output per unit dollar.
What's up guys, got another video for you here today. Master plan was a couple weeks ago. I just made a video recapping the first 30 minutes of it. It was so packed with information and I saw tons of people talking about it being, a dud or it wasn't great, the presentation was slow, they didn't reveal the new car. I thought it was one of the best days in Tesla's history. They put out a 25-year plan of how to transition the entire planet to sustainable energy. I don't see how that's not super exciting. Of course, they're not going to do it alone. They want to do 20 million cars per year, and they predict that there'll be around 80 to 100 million cars produced per year. So if you can just imagine a similar percentage in these other things from HVAC systems, they talked about planes and boats, battery storage and solar and wind deployment. There's so many subcategories that Tesla is going to go into over the next 20, 30 years. This is, in my opinion, one of the greatest investment opportunities of all time. And I was so excited after finishing Investor Day on March 1st or 2nd, whatever it was. And then I look online and everyone's talking shit about it. And I'm just like, I don't know if I'm either delusional or I don't know what people were watching. Because to me, it was just so densely packed with just nonstop amazing information about their plans for the next, from 5 years to 20 years, potentially getting into boats and planes. Like, how is that not exciting as a Tesla investor? So I'm gonna go over, even just recapping it for myself. It was so much into it. I've rewatched it twice. Now I'm gonna go over it with you guys and just break it down into little 30-minute sections because there is so much info in every 30 minutes. So let's go over the next 30 minutes. So we're just going over the first hour. You can rewatch my last video. I know it's a little bit long, but I'm just gonna continue pushing these out so you can learn a little bit more. I also recommend rewatching it because if you're just reading information thinking that it was a dud or just they didn't tell you anything new, I completely disagree with that. And let's get it started.
Alert, it's entirely feasible. Just looking at it from a growth rate perspective, how much do we need to grow the deployment of these technologies? We're talking about only a 3x growth rate in solar and wind deployment. Solar is already growing at a breakneck pace, as is wind. This gap is going to be closed really quickly. When we look at the electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. That growth rate is also going to close that gap is going to close pretty quickly as well. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global, energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy accelerates. And of course, our goal on this page is 20 million EVs per year and 1 terawatt hour of stationary storage per year, basically as soon as we can. And then, what about this investment? How do I have a reference point on this investment? Elon mentioned it's 10% of, 1 year's world GDP. Another way of thinking about it is how does it compare to what we're investing, like what we invested last year in the fossil fuel infrastructure? And it's 60% of that investment. So actually, building this sustainable energy economy is less than extending the fossil fuel economy from a year-over-year investment basis. So very doable.
So all these plans that they're talking about in this, especially the beginning of the master plan, they're not just 5-year plans. These are plans to transition the entire planet to sustainable energy by 2050. Can't just do it overnight. You can even see they predict $10 trillion of investment to transition the entire planet to sustainable energy, and 20 years of investment in fossil fuels at a 2022 rate would cost 14 trillion. And they already said their 10 trillion is somewhat overestimating, just trying to be conservative, but they think it's more 6 or 7 trillion. They talked about that a little bit earlier in the presentation. So potentially it could be half of what it would cost for the just fossil fuels over the next 20 years. So it just is honestly stupid to continue at the rate we're going. And then just having renewable energy, it's better for the environment. there's just so many positives to it. It's like, to me, it's a complete no-brainer. So Tesla leading the charge to transitioning the entire planet to sustainable energy, and all governments are already working towards it. Europe's talked about no more EV, ICE vehicle cells past 2035. So they're getting help from governments around the world that it's just clearly they're going to lead the pack in all areas.
Sustainable energy economy is less than extending the fossil fuel economy from a year-over-year investment basis. So very doable. When we look towards, does this fit on the planet? Absolutely. Less than 0.2% of land. As a reference point, the total land area intensively farmed today is 12.5% of all land. So, I mean, you drive around, you see some farms, but you don't see them everywhere. This is an order of magnitude, more than an order of magnitude difference between farming and what we're talking about for sustainable energy land.
Yeah, and it doesn't need to displace farmland
Of course
or
not, yeah.
forests or jungle or any kind of ecological preserve. It can be used in very sparsely populated desert regions.
Yeah. Barren areas,
Yeah.
Areas that are just not really fit for development or otherwise used. So,
Yeah.
I mean, 0.2% can fit into a lot of places.
Yeah, there's essentially no meaningful ecological impact. In fact, transition to a sustainable energy economy would result in a substantial reduction in current ecological impact.
This right here is amazing to hear. I've been trying to calculate how much total land would you need. It's pretty hard to do. They've talked about it in other investor days and other presentations that they've done, but 0.2% of the total land area of the United States, 12% of the land area is used for farming. So only 0.2% of total land area around the entire world can supply energy for the entire planet. It's like, I don't see how this isn't just a massive, massive collective effort to getting this done as fast as possible. There's an energy crisis in Europe. I talked about this in the last video. I was there over summer, and in Italy, you can only turn on your heater for certain parts of the day, and because they don't want overconsumption. It's like, imagine not having to deal with any of this, and it's crazy that in developed countries that they're still having to deal with something like this. It should be a #1 priority from all countries around the world to collectively try to build this, and I don't think that's going to happen, but I think it could be a great resource for optimists. How we talked about using, you don't have to displace, forest or, natural, lands that you want to preserve. You could do this in desolate areas that are uninhabitable. So I think this could be a great job for BOT in the future to deploy solar and wind farms around the world, maybe in the Sahara, in Mongolia, in Australia, and South America. There's so many places in Nevada, Utah. There's so many places around the world that you could, use this where maybe people don't want to live. You could just use it, have BOT deploy these solar farms, and then also repairing when needed. And then you don't have to have people living in these shitty areas.
Extraction side. So this is a cartoon that sort of gives you a sense for all the ore and the extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. The fossil fuel extraction disappears. We replace it with the materials required to fulfill the sustainable energy economy. It actually reduces. Now, it's not to say that we don't need to continue to explore, bring on mining and refining for the sort of specific materials for the sustainable energy economy. We do. But the investment and mass flows are all very achievable just looking at what is already happening on the planet. This is nothing out of scale of what has been done and is already being done. And then when we calculate it on a sort of, element by element basis, the resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. We're not breaking the resource bank for any of these materials. And then when we look at what really happens as we move forward, history teaches the more we look, the more we find. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing and Tesla's been growing and all the industries around us have been growing, the actual resource availability has increased, not decreased.
Yeah, there still seems to be quite a bit of confusion about lithium. Lithium is extremely common. It's one of the most common elements on Earth. There's no country that has a monopoly on lithium,
Yep.
or even close to it. There's enough lithium ore in the United States to electrify all of Earth.
Hearing that lithium statement about how there's enough lithium in the United States to put into batteries to supply the entire world to for transitioning the world to sustainable energy is just an unbelievable statement. Another exciting thing is Tesla's getting into lithium refinement. I believe it's close to like 80% of lithium refinement gets done in China. So we are super, super dependent on China for battery making, which just to me does not sound smart. We should be doing more refining because like they said, there's no monopoly for finding lithium in different continents, but it's really the refining that makes it a big deal. And if it's only done in one country, you could deal with, if they don't want to trade, or they could just rise prices. They basically have a monopoly on lithium refinement. So Tesla getting into lithium refinement in Texas is super, super exciting. I'm already, predicting that there's going to be certain companies that are putting out their goals for electric vehicle production, that they're just going to have some excuses that, they couldn't, get enough batteries, or there wasn't enough, lithium prices shot up, so they couldn't make it, where Tesla is thinking with an end in mind and realizing that they're going to need some lithium refinement so they're not fully dependent on China.
Yeah, and ultimately, this resource extraction, we go through this effort, we build these batteries, and then we recycle these batteries. So ultimately, we're doing this to build this sustainable energy economy, but the maintenance amount of ore that we require is really an order of magnitude or more, less, because of recycling. So in the end, a sustainable energy economy is within our reach, and we should accelerate it.
That's an excellent point too, is after you mine all these materials and you refine it and go through that that cycle that they talked about, you can recycle after that. So with oil, you're gonna, pull it out of the ground and then use it, burn it, and then it's gone. You just have to keep going through your reserves endlessly. Where with this, you mine the materials, you use them, you put them in batteries, use them for all different things, from cars, planes, battery packs, everything, to then when they can't be used anymore, you can recycle them.
And one of the most dynamic designs ever, I believe. It's definitely something that's going to change the road landscape.
Hopefully you guys saw it down there and you experienced it. It's definitely real. Those are real trucks. We're on our way to build them. But what that stainless steel opportunity did for us, it has let us rethink the factory footprint. We don't stamp those. That's a huge part of it. We don't even paint them. So our footprint got smaller, and we started to think about innovative ways to take those constraints and make great products.
But that constraint didn't really change the end result of the truck. It's a super dynamic truck, and it has all the functionality you would expect out of any of the other competitive trucks. And the best thing about it, it's coming this year.
So ideally, after all that, we would design, engineer, manufacture, and plan for automation happening together. It gives us the opportunity to question requirements. This is something that is fundamentally only available at Tesla. In the places I used to work and the top manufacturing companies in the world, they don't sit together.
Yeah,
we are one team.
Nowhere I know has all these teams together thinking about these processes from the very beginning.
In fact, all of those engineering teams, manufacturing, design, automation, they're all in one org. They all report to one person. We can't point fingers at each other, so we have to solve them together, which is the best way to innovate. A traditional way of making a vehicle is this. You stamp it, you build a body in white, you paint it, and you do final assembly. And what's interesting is these shops are dictated by the organizational structures that exist, and they're dictated by the boundaries that exist in the factories that are laid out. If something goes wrong in final assembly, you block the whole line, and you end up with buffering in between. This is at the tail end of its manufacturing optimization. Henry Ford first invented this assembly line in 1922. It's been 100 years, and it's really hard to make a change after 100 years. And when you watch it happen, it's actually really silly to a guy like me. You take all these stamp panels, you put them together, then you put them in a framing station, you build a body that looks something like a car, you put the doors on, and then you paint them. Once you get the color, you take the doors off, and then you start putting the interior inside the car. It comes in through the openings that already exist. I wish it went in like this big piece like this, but there's actually people coming in and out of the car. There's awkward movements. Then we lift the car up, we put stuff from underneath it, we put it down, then we put the seats in the car, and finally we close it all out with glass and we bring those doors that went away for a trip and we put them back in the car. Most of the time, we're doing this with a big giant car and moving it and doing really nothing to it at all.
What's funny, though, in this kind of whole process is that just recently Toyota just called this an engineering work of art.
True.
The Model Y.
That was humbling, but at Tesla, it's not good enough. If we're going to scale the way we want to do, we have to rethink manufacturing again. As part of the master plan, we have to make another step change in cost. We started this on Model Y when we made these huge gigacastings, and we deleted hundreds of parts. We simplified assembly with the Model Y structural battery, where we decided the floor should be a part of the car. The battery is the floor. We put the seats and the interior on the battery, and we bring it up through a big open hole, and we assemble it. And this allowed us to do things in parallel, fully rethinking the process and reducing the final assembly line by about 10%. And we thought maybe we could do this other places.
Yeah, I mean, in a way, the constraints become part of the solution rather than a problem.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long, and you have people working around it like we did in Model 3, and we change that to this process where we take different parts of the car, and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle, or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. I call that space-time efficiency. It has nothing to do with quantum mechanics. We can have that conversation later. But we get 44% more operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production hell, when we go to automate it, it's going to be a lot easier. In the end, that will probably look something like this, where we balance parallel and series manufacturing in a way where we only do things that are necessary, with a much shorter final line, blocking a lot less of the entire rest of the factory, so we can optimize material flow using the best practices. And what that means, it's going to look something like this, where we build all the sides of the cars independently, we only paint what we need to, and then we assemble the parts of the car once and only once. We put them where they need to go. The interior is attached from a bottom-up or a top-down strategy, so there's more access for those robots and people. We aren't moving heavy objects around and doing nothing to it, and it means we're doing more work on the car more of the time. And then when we take all of these tested sub-assemblies and we put them together, we finally assemble the car only one time, putting the sides on with all of their parts to a front and rear that was already assembled, carrying the floor in with the seats, and finally boxing it out with the doors one time, just like Cybertruck. So in the end, you get the same car, but it's not going to be a Model Y.
Yeah, this is not. Yeah. This is a Model Y for illustration, not the next-gen vehicle.
In the end, what does that mean? To increase the scale and adoption of electric vehicles on the orders of magnitude that we just showed you, we have to make constraints part of the solution. It leads us to greater than 40% reduction in footprint, which means we can build factories faster, with less CapEx, and more output per unit. Faster, less CapEx, more output per unit dollar.
That right there was, to me, one of the biggest parts of the presentation. Really just even understanding that is so amazing to see how just they've been cutting and cutting and cutting parts and making it more and more efficient, where Toyota is even talking about the Model Y as a work of art, the way that they manufacture it. And they're like, nah, it's not even good enough. Now seeing the 40% reduction in manufacturing footprint for the next generation vehicle and 50% reduction in cost. And this is a couple weeks past Investor Day, where the governor of Monterrey has already been saying that they are going to build this next generation vehicle in Mexico. So seeing it takes a smaller footprint and 50% reduction in cost, and they've already talked about that this factory is going to be as big as Giga Texas, if not much bigger. So if it has a much smaller footprint, how many cars are they going to produce at this Mexico factory? And at a 50% cost, this is just so exciting. You know that this cheaper car is about to come out of Mexico. You know, is it going to be 2 million cars there, 4 million cars? How, you know, big is this plant going to be, and how many cars are they going to produce? That right there is the biggest part that they're saying. It's the next generation vehicle is a 50% reduction in cost from the Model 3 and Model Y. You can get a Model 3 today in the United States for around $40,000, less with the with incentives. So how cheap is this car going to be with full self-driving? This is what's going to take Tesla over the edge, in my opinion, is this next generation vehicle. They're already close to solving full self-driving completely. I think they'll have that within the next couple years for sure. It's already unbelievable right now, but this is what is going to be huge. And then as they master this, what's going on in Mexico, hopefully this can, come out next year in 2024. They can, replicate that or even improve on that and then build the next factory. But I think this is going to be so monumental to Tesla and helping them get to that 20 million cars per year. I'm really curious to know how many cars they are going to produce out of this factory in Mexico. Let me know what you guys think, but this right here was one of the main highlights of the presentation. They don't need to introduce what the car is going to look like. I could care less. Saying the 40% reduction in manufacturing footprint and 50% reduction in cost, that's what you need to know.
So I think our track record proves that we can deliver the best cars, and we deliver the best cars in spite of, because of these constraints. And I'd love to really show you what I mean and unveil the next gen car. But you're gonna have to trust me on that until a later date. And I promise we'll always be delivering exciting, compelling, and desirable vehicles, like as we always have.
Have we ever not? We always do.
But what else is Tesla known for?
Speed. So with that, I want to bring on Colin, who's in charge of making our cars go fast.
Thank you, Lars. Thank you, Franz. My name is Colin Campbell, and I have the real privilege of leading powertrain engineering here at Tesla. We make the fastest cars that you can buy for the money, whether they're electric or gas. And the Model S Plaid that we're looking at here, it has more than 1,000 horsepower, and pound per pound, the motors in that car are as powerful as jet engines. Our cars are super fun. People absolutely love driving in them. And the other thing that you probably all know about our powertrains is that they're efficient. Our cars go 25 to 30% further than other EVs in our class for the same amount of efficiency. But at Tesla, efficiency means more than just reducing how much energy the cars use. It's about how we develop, how we manufacture, how we refine, and how we scale the powertrain. Now, the Model 3 and Y powertrain is a great example of this broader meaning of efficiency. So since we launched it back in 2017, we've continuously improved that powertrain and the factory that builds it. So the drive unit, the engine of the car, is 20% lighter for the same power. We use 25% less heavy rare earths than when we started. And the powertrain factory, which is behind me today, is 75% smaller and 65% cheaper than the one that we originally built. And what I really want to emphasize is that we did all of this without compromise.
That is another amazing part of Tesla, is Elon's talked about it, is making the factory a product. it's so amazing to even hear that concept, but it's so true. He talks about, prototypes are easy, manufacturing is hard. Toyota calling, their manufacturing process a work of art, and 20% lighter drive unit, 25% less rare earth metals, 75% smaller powertrain factory, and 65% cheaper powertrain factory. So they're just getting more and more and more and more efficient. Wait till the new Mexico factory. And think about the even investment. They're talking about the Mexico factory is going to be around $5 billion of investment. $5 billion, let's say, eventually produces 2 million cars per year at an average cost, let's say, of $30,000. That's $60 billion a year in revenue from a $5 billion investment. $60 billion per year with a $5 billion investment. It is so insane how efficient they are. You work on the factory being the product instead of making the car as perfect as possible, but then you don't know how to build this in mass and do it efficiently to make a profit. It's just so genius, really, and that's what's really exciting. And there's no other company that's so focused, that has the manufacturing as Tesla does, and is efficient and is profitable. And that's why you see Tesla has the highest operating margins of any mass producing car company. It doesn't, beat like Lamborghini and Ferrari, but other than that, of mass producing cars, Tesla is by far the leader, sometimes almost 50% more than like VW and Toyota and different companies like that. That's enough for today. We saw the Cybertruck, how that's engineering genius. We talked about, the factory being the product, and how a $5 billion investment potentially with this Mexico factory could produce $60 billion in revenue per year. It's unbelievable. And what else did we go over? Oh, we went over how only 0.2% of the total land area of Earth could, with solar and wind and then the battery packs, could transition the entire planet. Hopefully we can get a collective effort to make that transition as fast as possible. Tesla's talking about, helping, accelerate that so it can happen by 2050. I believe it could happen faster if we had better people in power, but who knows if that's gonna happen. So I think Tesla's just gonna accelerate it. When bot comes and they could be producing millions of bots per year, it's gonna accelerate even faster. So I'm excited to see the acceleration of bot as we go into the next, few years. The Mexico factory, the Cybertruck coming out this year, the Roadster coming out next year, the next generation vehicle coming out next year, the new Megapack factory in Lathrop. There's so many catalysts for Tesla, and it's trading at what it was a few years ago. Just consider yourself lucky. This is one of the greatest times to be a Tesla investor. I thought a couple years ago when it started shooting up, I was like, I was a little pissed that I didn't get enough shares at a lower price, but now I just see this as the greatest opportunity ever. People were scared when it was at 100. I saw that as an even better opportunity of what we're at now. It's below $200, which pre-split was around 600. I thought that was the greatest deal a couple years ago when it was trading at 600. Now we're getting that years later as they're gonna get to 2 million cars this year. The new factory, couldn't be a better time to be a Tesla investor. The world, as Warren Buffett's always said, be greedy when others are fearful and be fearful when others are greedy. Right now, I think a lot of people are scared with the bank situation, Russia and Ukraine. People are scared right now. This is the time to just buy in. What if it goes back down to 100? Buy more. Maybe don't use all your cash now because, but I would just keep buying, just consistently. Sorry, this isn't financial advice. That's just personally what I'm doing. Every dollar I get, I'm putting into there, and just keep, in the future. I made a video of talking about how many shares I believe you need to be a millionaire in the future. I think it's close to around 500 shares. We can go to 2,000 a share. At 500 shares, at 2,000 shares, $1 million. I plan to have way more than 500 shares by 2030. So yeah, I want to be in the thousands of shares. So again, sorry I'm rambling now, but this is exciting. I've gone over 1 hour of this investor day and the master plan. There's still 3 hours left in the presentation. It was so energy packed, tons of people talking crap about how it was just a useless presentation, but I couldn't disagree more. One of the coolest days in Tesla history of just this information that they're giving you. What other company is doing 4-hour presentations of just showing a 20 to 30 year plan for their future? It's like, I don't know if people are spoiled from this, but yeah, that's all I have for today, guys. Thank you for listening to me ramble, but I'm grateful to be doing this. I'm happy to be living in the time Elon Musk is just changing the world completely. No one's even come close to what he's doing. The greatest engineer, greatest entrepreneur of all time. I'm a fanboy, I know it. That's why I call myself the Tesla Hyperbole. But thank you guys for watching. My name is Sean, and I'll see you guys next time.